Okay. So if you guys could take out that special topics packet, page 73. So this activity is designed to push your thinking without your calculator. Okay? Area, volume, cross sections, really popular topics could show up as one free response question. When it shows up that way, it always is a high scoring question, especially at Southwest, because I do a mighty fine job at that. So the goal with this question is you don't need a calculator. We're going to focus on the setups. We're going to focus on the integral that you would need in order to find the answer. Even on a calculator active question, you want to show the calculus. You want to show the setup. Even if you don't type it in correctly into your answer, having the setup is good. Do you have your notes somewhere? Okay. All right, so the graph of two functions, y equals e to the negative x squared and y equals 1 minus cosine are given below. For the sake of the activity, label the intersection point of the two functions as a comma b. This podium and I are not going to do so well. Find the area of region R in terms of x. I would think this is an easy, kind question. Take a minute, see what you can do. What's your setup? Don't type anything into the calculator. I don't need that. Okay, seeing a whole lot of good stuff. Area problems always involve an integral. And Carlos, there's no need to do anything on the calculator. No, we're just focusing on the setup. Okay, I want the area in terms of x. What kind of an integral? dx or dy? This has to be a dx. Now, the way that we used to do area and the way that I want you to think about area is we'd always think about like that slice, right? You think about the slice of this little rectangle and you say, okay, gosh, well, how long is that slice? How do I determine the length? Top minus bottom. This is what I saw in a lot of papers. So e to the negative x squared minus 1 minus cosine of x. And you have to have the parentheses. Without the parentheses, this is not going to work. So you're going to do an integral of e to the negative x squared minus 1 minus cosine of x. Integrate with respect to x. From where to where? You're going to go from 0 to x equals a. That's why I wanted it labeled x equals a. Now, before we leave this question, and this is the right integral, what's important to note is, what if I had made the slice over here? How would you find the length? Same way. What if you did the slice here? Same way. No matter where you make the slice for this particular region, it's always top minus bottom. The top function stays the same. The bottom function stays the same. One integral. Yeah?
Aren't you supposed to like separate them and have a second integral because of like the first shading and then the second shading? You see what I'm saying?
Because of the first shading and the second?
Yeah.
If I wanted, don't write this down, but if I wanted you to go past the intersection point, then your top function switches, your bottom function switches, you would need a different integral. But since I'm only going to the intersection point, we're good. And all the friends are okay? All right, I would think this is the kind, easy question. Maybe 1 point for the integrand, maybe 1 point for the limits. You would type it into your calculator does all the work, out pops an answer, and everybody's good. Now for the unkind question. Find the area of region R, the exact same region in terms of y. We'll talk in a little bit. What are you going to do in terms of y? finding the area in terms of y. Some things have just changed. Pedro's off to a good start. He knows what changed. Okay. Alright, so some folks are making some good decisions here. It's a dy integral, you're slicing this way. Right, we're doing horizontal slices. Horizontal slices are always tricky. What I saw Pedro do, and I think this is such a smart choice right from the get-go, he said, okay, I'm going to do an integral. And he said, I'm going to go from y equals someplace to y equals someplace. I may not even know what the y's are, but man, it's everything's in terms of y. We're good? Okay, where do you start integrating?
0 to 1.
We're going to start down here at y equals 0, and I heard Jackie just say, like, well, the y value up here is 1. Down here it's 0, 0. And so I might initially think I'm going to go from y equals 0 to y equals 1. But if you start paying attention to the slices, look at those slices. Something happens. Something really important happens. They change. How I determine the length of the slice is different down here from the way it is up here. Everybody okay with that? Yeah. Because of that change, you need two integrals. You're going to do an integral from a place to a place, add it to an integral from a place to a place. Now, how do I know where to switch? Right at the intersection point. Because the way I find the length below is different from above. I'm going to go from y equals b, from y equals b to y equals 1. I saw that in a whole lot of papers. Now the really tricky part, how long is the slice? How long is that slice? Because we're slicing this way, we're not doing top minus bottom, we're doing right minus left. Yeah. The problem, though, is the guy on the right, let me write it up here, says 1 minus cosine of x, and I'm doing a dy kind of integral. So the math that you need to do, solve this for x. Hopefully not too bad. You're going to say, okay, y minus 1 equals negative cosine. Next thing, divide by negative 1 or multiply by negative 1. So negative y plus 1 equals cosine. And now this is where your trig either comes shining through or it's a disappointing hot mess. Negative y plus 1 is equal to cosine of x. I want to get the cosine, the x by itself. Don't tell me divide by cosine, that's not a thing. You need the reciprocal of the cosine, which is, actually not reciprocal, wrong word, sorry. Put a bad word in my mouth. It's not the reciprocal, it's the inverse. You need the opposite of the cosine, and that is arc cosine. So arc cosine of negative y plus 1 is equal to x. So the slices down here, right minus left, it's going to be the arc cosine of negative y plus 1 dy, and nobody needs you to integrate that. Nobody wants you to do that. To integrate from b to 1, now I look at my other curve, and what is that? Y equals e to the negative x squared. I bet this one we're going to be much more successful with. To get to the x, we have to take the natural log on both sides. Those guys are inverses. The natural log of y is equal to negative x squared. To solve for x, divide by negative. You've got to divide by that negative first. And then you're going to take the square root, and this messed up the last class. Whenever you take the square root, you've got to consider the positive and the negative version. The positives or the negatives. Look at the graph. All of these points over here, you're saying, do I take x equals the positive version of this or x equals the negative version of that? Look at the points. All the points that I need have a positive x value. So that's why it's going to be x equals the positive version. Your integral then becomes the square root of negative natural log of y dy. Yeah. You're right, you don't like a negative underneath the square root sign, but the natural log of y isn't positive, it's not negative, it could be either 1, depending on the value of y. Is everybody mostly okay? Okay, I know this one was tricky. See what you can do the next one. In this case, they might mark it. Right, when you're integrating, the integral of 1 over x is natural log of the absolute value of x. That's when you need the absolute values. That's the Yeah.
Is this right?
It is mostly right, but it's not 100% right. You've got some good ideas here. Okay, first of all, the 1 cosine of x is a little messy for me. You mean 1 minus cosine of x? And I know that you're like, that's so small, but it means something different without it. The other issue is you haven't defined your upper limit. Oh, I'm sorry, it bled into the other thing. My bad. But it's also not 1.
But isn't it from 0 to 1?
No, it's from 0 to the intersection point.
That's not 1?
Well, that's why what I told you to do, Jackie, label it as A comma B.
So then it will be 8?
Yep. All right, volume of the solid form and region R is rotated about the x-axis. I've heard most people asking the just right question. You're taking this region, you're spinning it around the x-axis. The just right question that everybody needed to ask themselves first: solid or hollow? This has to be a hollow object. So if you've got a hollow object, and I've seen this on a whole lot of papers, you know it's going to be pi, integral from place to place,
0 to 8.
big radius squared minus small radius squared dx. You're already moving in a good place. Where do I start integrating? 0. Where do I end? A. To determine the big radius, remember you're taking this region, you're spinning around the x-axis, you start on the axis of rotation, and you go up to the outside curve. That's big radius. Small radius, that's that guy. How long is the big radius? From here to that top curve. Top minus bottom, e to the negative x squared. So this is e to the negative x squared minus your small radius. You go 1 minus cosine of x down to the x-axis is 1 minus cosine of x, the whole thing squared. Usually the way the College Board does this, if you get the pi in the limits, you get 1 point, and walking around a lot of people have the pi in the limits. Hold on, Roberto. And then the integrand, this part here, is usually worth 2 points. Roberto.
So if we were to put e minus negative x squared minus 1 minus positive x.
And then the whole thing squared? Right. So Roberto's question was, what if instead of like big radius squared minus small radius squared, what if I do this? Are those the same or different?
The same.
Let me ask this question then. 5 squared minus 3 squared compared to 5 minus 3 squared.
The unit inside parentheses.
5 squared minus 3 squared compared to 5 minus 3, the whole thing squared. These guys are, these are different, which means these are different. Don't do this guy here, big radius squared minus the small radius squared. Okay, keep going.
So this is not right.
Right, so you did the big radius minus small radius squared. You would probably, Jackie, if you had your limits of integration at 1 point, and then your integrand, you'd probably get 1 point out of the 2, but I want you to get 2. It's always big radius squared minus small radius squared. Keep going. Hi there. Keep going. It's up there.
Like pretty much the same thing as the top thing. One to B. And B. Wait, no, you started zero to B and then B to That's not real
The volume of the solid formed when you spin around the y-axis. Spinning around the y-axis, hollow or solid? Hi, I'm trying to teach a class. Sorry to interrupt the conversation the two of you are having right now. I'm just, thinking about the fact that your AP exam is on Tuesday. Volume of the solid form in region R is rotated about the y-axis, solid or hollow? Solid. Solids should be easy. However, you're taking this region over here and you're spinning around the y-axis. So we're going to be slicing this way. We've already established that slicing this way is going to be a problem. Okay? Two different integrals. Has to be two different integrals because you're switching over here at the point A comma B. So I'm going to do pi. I'm going to do an integral from 0 up to B. I need the radius. How long is the radius here? I think we had already gone through and we did this one. And what was it? The arc cosine of negative y plus 1? Right, that's the x equals version. So this is going to be arc cosine of negative y plus 1, the whole thing squared dy, plus pi. You're going to do an integral now from y equals b to y equals 1, square root, negative natural log of y, the whole thing squared dy. The dy ones are trickier, always. How many of you guys honestly had that as your setup? 2 people, 3 people, 4 people, 5? Nice. Okay, volume of the solid form when region R is rotated about the line y equals negative 3. That's the last one. Y equals negative 3. Think about that. Get it set up. We'll talk in a minute. No, but for the y ones, I do it for myself. And for you all, so you're like, oh, it's a y. You're the y. It's the y. Yeah.
So you know how you lose everything on these squared?
You could absolutely could just cancel out and that would be okay. Absolutely. Yep. But because I'm just looking at the setup, I'm putting this in the category of don't simplify. Right? Just don't do it. Because if you're like even a little unsure, you're wasting time. Yep.
Would you add things to this one?
Yes. Negative 3 is down there.
I told you, yeah. You're the one that told me. You said no. I'm just explaining what you want. I said you added it, right? And you said no.
All right, let's land the plane with this one. Volume of a hollow object, big radius squared minus small radius squared. when you're going after the big radius, always start on your axis and go until you hit that outside curve. That's big R. Little r, do the same thing, but you stop at the outside curve. How long is that radius?
E to the negative x squared minus
Oh, wait.
Top minus bottom. It's always top minus bottom, or it's right minus left. Top function, e to the negative x squared, minus the bottom function, negative 3,
So plus 3.
which means plus 3. Okay? Obviously, I want you to know that that's plus 3, but honestly, on the free response part of the test,
It don't matter.
I'm not going to bother. Okay? Small radius, 1 minus cosine of x minus negative 3. The whole thing squared. You're integrating from 0 to a. With area and volume, it's all about the setups. If you can get the setup right, after that, it's just type it into the calculator. All right, I know I didn't get a chance to sign the